This is a two-part video for an Arduino project that uses MATLAB and Simulink. In the first video, we'll use MATLAB to develop an algorithm. Then in the second video, we'll use Simulink to program that algorithm onto the hardware for standalone execution. For this demo, I'll use a photoresistor to determine the amount of ambient light, and then use that measurement to calibrate and control a gauge. As it's wired, a higher voltage at the analog pin 0 corresponds to a higher light level. And we'll start by taking a look at the hardware used for this demo. Here I have an Arduino Mega 2560. And I'm plugging in an Adafruit Motor Shield V2, which is connected to the breadboard with the photoresistor on it. As the shield, you can plug it straight into the pins on the Arduino board. Like so. This motor shield has the ability to control up to 4 DC motors, or 2 stepper motors, and up to 2 servo motors. I'll just use a servo motor for this demo. Here's an example of a servo motor. This part can be rotated to a desired position, and it has 3 wires, a signal, a power, and ground. But rather than use this servo motor, I actually built myself a display. So this gauge, you can see I built it from some scrap cardboard that I found, and I installed a servo motor into the center there. So the servo is connected to this needle, and by positioning the servo motor, I can position the needle to any desired position on the gauge. Alright, so we have the input device, which is the photoresistor. We have the output, which is the servo. So here I've built a script which goes through the steps that we'll use for controlling this gauge. We'll create a variable to represent the Arduino board and specify the port, the board name. And now, because we're using this add-on, which is this Adafruit Motor Shield, we also want to specify the libraries for that add-on. And so we've created the variable A to represent the board. Similarly, we can use the add-on function and the servo function to create variables to represent the shield and the servo motor, respectively. You can see the servo motor jumps to attention, and we have these 2 variables. You'll also notice that the servo variable mentions that the pin is D10. If you look closely at the board, you can see that servos 1 and 2 up here are addressed through pins digital pin 10 and 9, respectively. So how can we drive that servo motor to positions that we want? Well, there's a function called writePosition, which can write the servo motor to a desired position. So I want to set up this gauge so that I can know where the boundaries are on the gauge, the far left and far right edge. So writePosition takes values between 0 and 1, and it turns out that 0 is positioned to the far right, and 1 is a position at the far left. So if I want to figure out the value for the left edge of this left tick on the gauge, that's going to be a little bit less than 1, right? And one way you can tune parameters in a MATLAB script, if you have it broken into sections, is to right-click on the parameter you want to tune and select Increment Value and Run Section. Alright, so now I can tune this 1 to be just a little bit smaller, maybe decrease it by 0.1. You can see that gets closer to the left tick mark on the gauge. Decrease it again by 0.01. We can see that if you look straight down at the gauge from above, that's pretty much right on the line there. Alright, and I can similarly do the same thing, adjust this variable to find the right edge of the gauge. And that's at about 0.03, and that gives me the range as well. So that's how we control the servo motor. What about reading in the values from the photoresistor? Well, it's on an analog pin, so we can use the read voltage function to read the value of that pin. And the way I have this wired up, a larger value, so these values are still between 0 and 5, and a larger value corresponds to more light, whereas a smaller value, if I cover up the sensor, corresponds to less light on the photoresistor. So right now it's getting a fair amount of light. Now I have to make a decision about how I want to how I want these light level values to correspond to positions on my gauge. And the way that I'd like to do it, you can choose your own approach, but my approach is going to be to keep track of the light level values that I continue to read, keep track of which is the smallest and the largest value, and then scale any future reading in between the smallest and largest values. So to keep track of those values, I'll initialize them to be the current reading, and then I'll run continuously and position the motor. Right? So this is the core logic of my algorithm, is in this loop here. I'll expand it so you can see all of it. And so it's a while loop. If you're not familiar with while loops, that just means that this loop, everything in this section of code will continue to run until I meet some condition. In this case, that condition is when I get to 30 seconds. And this loop does three things. So the first thing it does is that it reads in the value using that read voltage command that we saw. And the last thing it does is it writes out the position of the servo motor, right, to the desired position on the gauge between 0 and 1. And everything in the middle is how we convert from some voltage reading to the position that we want. Right, so keeping track of the maximum and minimum values that have been read so far, updating those, updating the range, and then scaling that value somewhere between the gauge limits. Right, so it's fairly straightforward. So let's see how it works in practice. All right. Okay, so you can see initially it's jumping all over the place, but if I calibrate it by giving it a low value here, remove my hand, now it's at a high value. I can also take a flashlight. I have a MathWorks flashlight here, and if I shine a light onto it, now it's calibrated to this as the high value, and when I move that away, we can see the ambient room lighting that we have is now slightly lower than that high value from the flashlight. All right, so as I cover it up, it moves to different points on the gauge. All right, so that's been 30 seconds. And so you can see the algorithm kind of worked as desired. Now I mentioned that it had three different sections, right? We have reading the input, we have doing the algorithm to convert the input to an output, and then we have writing the output. All right, so with MATLAB, you can take your algorithm and put it all into one line of code if you encapsulate it all into a function. Right, so this is just a function I have written, gauge position. You can see it contains that same code that was in the body of the loop, and has a few additional lines up here to use persistent variables to keep track of the minimum and maximum values. All right, so again, this works the same way as the code in the previous section, but it's just a little bit more compact and easy to read.